Yes, good afternoon, everyone. So, we were discussing about solubility, right? So, so these are the things which we have discussed in our earlier classes. Okay. So previously we have seen the different methods of expressing the concentration of solutions. So we have seen what is mole fraction, molarity, and molality, right? And based on that, we have solved problems also. Okay, examples we have seen. Then we had started about solubility. Okay, what do you mean by solubility? So solubility of a substance is the maximum amount, okay, that can be dissolved in a given amount of a solvent at a specific temperature. So we have understood what is solubility. Okay, then we had started with, so these are the factors which are affecting. So we are going to discuss one each factor, okay, after completing the solubility of solid in a liquid. Okay, so what do you mean by solubility of a solid in a liquid? So our solid will be a solute. Okay, our solid will be what? Our solid will be a solute, and you know that solute will be present in what? Smaller quantity. Solute will be okay, solubility. So solubility of a solid in a liquid. So here our solid, okay, is a solute, and solute will be present in smaller quantity, and solvent is a liquid. Okay, solvent will be present in larger quantity. So we had seen in the previous class about dissolution. Okay, dissolution means what? Okay, what do you mean by dissolution? So dissolution is nothing but dissolving of solvent. Okay. How the solvent gets dissolved. In simple words. Okay. In simple words, dissolving of solute. Okay. Dissolving of solute in a solvent is called as dissolution. Okay. So what do you mean by dissolution? Then we had seen one more term. So I'll take a fresh page here. Okay. We'll discuss it here. So dissolution. Then we had discussed something called as crystallization. Okay. So we'll discuss one by one. So what do you mean by dissolution? Dissolution means what? Dissolution means dissolving of solute. Okay. Dissolving of solute in the solvent. Okay. How the solute gets easily dissolved in the solvent. Suppose I take solute as NaCl. Okay, what is NaCl? NaCl is sodium chloride. Okay, our salt, common salt. So NaCl, so this is solid. Okay, now this NaCl will get dissociated into Na plus and Cl minus ions. Okay, it gets dissociated into Na plus and Cl minus ions. Ions means it will be in aqueous form, right? In the aqueous form. Suppose I take a beaker. Okay. In the beaker, what is present? This is the, okay, the lines represent your solvent. This represent your solvent. Solvent is our liquid. Okay, this is representing your solvent. And these are the solute particles. Okay, this solute particles is your NaCl. Okay, it is your NaCl, that is your solute. That is your solute, which is solid. Okay, so what is happening here? So solute is getting dissolved in the solvent. So when you add NaCl in water, what will happen? NaCl will get dissociated into Na plus and Cl minus ions. Okay, aqueous ions. So this is called as dissolution. What it is called as? It is called as dissolution. So this we have understood. Okay, what is dissolution? So what will happen when we are adding the solid, okay, into the solvent? It will get dissolved. And what will happen to the concentration of the solution? The concentration of the solution will increase. Okay, and this process is called as dissolution. Now, at the same time, what is happening in crystallization? Okay, what is happening in crystallization? Crystallization, the ions, okay, Na plus ions, that is which is aqueous, plus Cl minus ions, which is in aqueous, will get associated to form NaCl solid. Okay, NaCl solid. What will happen in the beaker? Whatever the Na plus and Cl minus ions are there, okay, in this solution, in this, okay. So this will get collide. Okay, it will collide with each other. It will get collide with each other. It will, when it will collide with each other, what will happen? It will collide to recombine. They will recombine. So these Na plus ions and Cl minus ions, they will collide with each other and they recombine to give you NaCl, okay, NaCl, which is again solid. So this is called as crystallization. So what is dissolution? So dissolution is when solid, okay, solute dissolves in, when solid solute dissolves in the solvent. Okay, when the solid solute dissolve in the solvent. And what is crystallization? Crystallization is what? Solute particles. Okay, solute particles in solution, right? The solute particles are present in the solution. Okay, they will collide. They will collide to get precipitate. Precipitate means what? Precipitate means they will get settled down. Okay, they will get settled down. Okay, this is called as uh, crystallization. Is it clear now? What is dissolution? What is crystallization? Crystallization means what? The ions which are present. Okay, these ions will collide with each other and they will recombine. Okay, to give you the solid NaCl that will be in the crystallized form. Okay, they will be in the precipitated form. Fine. Now, okay, so here, suppose now there is one state. Now, suppose I take here solute. Okay, solute. How the solute will be? Solute will be in the small particles like this. Okay, solute will be small particles. Okay, they will be present in the smaller quantity. Okay, in the smaller quantity. And the solvent is our liquid. Okay, solvent is our liquid. So that will be present in the larger quantity. Okay, this will be present in what? It will be present in the larger quantity. Now this, what will happen when the solute will get dissolved? Okay, when the solute will get dissolved in this solvent, then what process is formed? The process, it will give you solution. Okay, this will give you solution. So when smaller quantity of solute is dissolved in solvent, which is in larger quantity, it gives you what? It gives you solution. Okay, and this process is called as what? Of dissolving the solute into solvent is called as dissolution. Is called as what? Dissolution. Okay, and when solution, now what is happening? This solution will, what will happen to the solution? The solution here will again give back the solute and solvent. When the solution, when it gives back again the solute and solvent, then this process is called as recrystallization. Okay, recrystallization. I gave you the example of NaCl. So when NaCl gets dissociated into Na plus and Cl minus ions, okay, that is dissolution. And this Na plus and Cl minus ions, they will collide. Okay, they will collide with each other and they recombine to give you NaCl. Okay, in the form of precipitation, and this is called as crystallization. Okay, this is called as recrystallization. So this is our solution. So this is our solution, right? So solute will get dissolved. This to give you solution, this process is dissolution, and solution will give back your solute and solvent, then it is recrystallization. So this is a dynamic equilibrium is reached. Okay, so this state is called as what? This is called as dynamic equilibrium. So a state is reached, or a state is reached where solute and solvent will give you a solution, and solute will give you solvent and solute. Okay, solution will give you solute and solvent. So this state, okay, at which this process occurs, okay, is called as dynamic equilibrium. Okay, this is called as dynamic equilibrium. So is it clear what is dissolution, what is crystallization, and what is dynamic equilibrium? Yes, students? Is it clear now? Okay. Others? Anybody has doubt, you can ask me. I'll unmute. Okay, you can unmute yourself. I've given you the option. If anybody wants to ask any doubts about dissolution, crystallization, you can ask. Anybody has doubt? It is clear. Okay, dissolution, crystallization, and dynamic equilibrium. Okay, fine. So next there is something called as saturated solution and unsaturated solution. So that we'll see now. So should I clear this?
Yes, ma'am.
Okay. So next is something called as saturated and unsaturated solution. Now, suppose I have sugar. Okay. Sugar, I have sugar. Now this sugar, when I add in water, okay, I take a bit of sugar. I take 1 tablespoon of sugar and I'll start mixing in I have a glass of water. This is not beaker. Okay. This is a glass. This is a glass and I have a tablespoon of sugar. Now I'll add 1 teaspoon. I'll add 1 teaspoon of sugar in water. Okay. It will get mixed. It will get mixed. Okay. Now again I'll add 1 more tablespoon of water. It will get mixed. Again 1 tablespoon. Like this. Okay. So there will be one limit. Okay. There will be one limit, one point. Okay. One point will reach that sugar will start deposited at bottom. Okay. So suppose, so you can mix 1 tablespoon. You can mix another 1 tablespoon, 1 more tablespoon. But after some limit, okay, after some limit, the sugar will not dissolve in water, but it will get deposited at the bottom. Okay, it will get deposited at the bottom, and this is called as precipitate. Okay, this is called as precipitate. I'll write the short form. Okay, please understand precipitate. I'll be writing as PPT. Okay, so precipitate. So at a one point will reach where the sugar will start to deposit at the bottom. Okay, so till the sugar gets deposited. So till when the sugar was getting mixed, I'll write here. So till sugar gets mixed in water, okay, till the sugar gets mixed in water, this is called as unsaturated solution. What it is called as? Unsaturated. It is called as unsaturated solution. Okay, till the sugar gets mixed. How much level? Okay, till how much the sugar is getting mixed into the water, then it is called as unsaturated solution. Okay, suppose I have this beaker, I'm adding the sugar. So this is getting mixed. So this is what? This is called as unsaturated solution. Now, one more example. Now, when the sugar is starting to get deposited, okay, after the sugar has been mixed completely, okay, now this is water droplets, okay, not the sugar precipitate. So I'll represent with another color. So this is your water and your sugar is getting mixed here. Okay, one more case where what is happening? I have a beaker. Okay, I have water in that. Okay, I have added too much of sugar. Okay, I have added too much of sugar. Now what is happening? The sugar, after adding too much of sugar, a limit is reached. Okay, where the sugar is getting precipitated at the bottom. It is getting precipitated at the bottom. So what is this? When no more, okay. So a solution in which no more solute can be dissolved, okay, at a particular temperature, and pressure, okay, is called as saturated solution. Is called as what? Saturated solution. Means what? a solution. Now there is no, the limit is reached where no more sugar is getting dissolved in that. So the sugar is getting precipitated. So this is called as saturated solution. Okay, this is called as saturated solution. So when a limit is reached and the sugar is starting to get deposited at the bottom, you can try this at your home. Okay, but unnecessary, there will be wastage of sugar. Okay, so if you want, you can try this also. So at a particular time, what will happen? When the sugar is getting mixed, okay, it is dissolving, it is called as unsaturated. Okay, after a limit is reached and the sugar is starting to getting deposited at in the glass, okay, this is a saturated solution. In saturated solution, what is happening? In saturated solution, maximum solute is getting dissolved. Okay, maximum solute is getting dissolved. So this is a saturated and unsaturated solution. Is it clear? Is it clear what is saturated, what is unsaturated?
Yes, ma'am.
Yes.
Okay. Anybody has doubts, you can ask. Okay. So we'll move forward. So I'll clear this. So next is, so what will happen in saturated solution? Okay, in saturated solution, the rate of dissolution. Now you know what is dissolution, what is recrystallization. Dissolution is dissolving of solute, okay, in the water. So the rate of dissolution is equal to rate of crystallization. So what is saturated? Saturated state is reached when the rate of dissolution is equal to rate of crystallization. So remember this, okay? So in saturated solution, rate of dissolution is equal to rate of crystallization. So now, so these were the terms, okay, which are involved in the solubility of solid in liquid. Now we'll see the factors, okay. So what all are the factors which are affecting? What are the factors which are affecting? So I'll play the slide now. Okay, so these things we have seen, what is saturated, unsaturated. Next are, what are the effect? Okay, so what are the factors? So I'll write it here. So factors affecting the solubility of solid in liquid, okay, affecting the solubility of solid in liquid. First is the nature of solute and solvent, nature of solute and solvent. Next is temperature, and next is pressure. Okay, so when we talk about nature of solute and solvent, you have to first I'll write it here. Nature of solute and solvent. You know that solute will be present in less quantity, solvent will be present in more quantity. Suppose I'll take the example of sugar in water. Sugar in water. So this is an example of solid dissolving in a liquid. Okay. Now remember, when you are talking about nature of solute and solvent, you have to remember like dissolves like. What do you mean by this now? Like dissolve like. Okay, means polar solute will dissolve in polar solvent. Okay, polar solute dissolves in polar solvent. Okay, and second one, non-polar solute dissolves in, so two conditions, dissolves in non-polar solvent. So whenever you have a polar solute, it will dissolve in polar solvent itself. And whenever you have a non-polar solute, it will dissolve in non-polar solvent. If I give the example of polar solute, okay. So I'll take the example of polar solute. Example, salt. Yes, salt is NaCl. So NaCl dissolves in water. Water is what? Water is also a polar. Now, second example, sugar. Any sugar. I'll take sucrose sugar. Okay, sucrose dissolves in water. Okay, dissolves in water, H2O. Okay, So these are the examples of polar solute dissolving in polar solvent. Now, second, if I take non-polar solute dissolving in non-polar solvent, the example is naphthalene balls. Do you know what you mean by naphthalene balls?
No,
Yes,
ma'am.
ma'am.
Naphthalene balls and anthracene.
What is naphthalene ball, ma'am?
You use in clothes, see white color balls, it will be what you call damper gori, gurge.
Oh, हाँ, ma'am.
Yes,
Understand.
so that is your naphthalene ball. Okay, so
Okay.
you use in for the clothes. Okay, for in the cupboards and all you put them. Right, so those are naphthalene balls. So naphthalene balls is also non-polar. Anthracene is also a compound. Okay, so that is also non-polar. So you can take the example of non-polar solute as naphthalene balls and anthracene, which dissolves in non-polar solvent like benzene. So benzene is a non-polar solvent. Now, do you know what is polar solvent and what is non-polar solvent? Sorry, polar and non-polar by the word.
Yes, ma'am.
Okay, for the others who don't know, I'll just explain it. Okay, Yamuna has, okay, I'll explain you. Wait. So polar. Polar means what? Okay. So polar molecules will they will arise due to the difference in electronegativity. Okay, polarity. So polarity will be induced on such molecules because it is polarity is associated due to electronegative differences. Now between hydrogen and chlorine, you know that chlorine is highly electronegative atom. So what chlorine will do? Chlorine will tend to pull the electron towards itself. The shared pair of electrons, okay, the electrons are shared between the hydrogen and chlorine. So what this chlorine will tend to do? It will tend to pull the electron towards itself. So as a result, what will happen? There will be partial negative charge developed on chlorine and partial positive charge developed on hydrogen. So this is polarity. Okay, these are polar molecules. So whenever suppose water, H2O, okay, H2O. So there is one oxygen and two hydrogens. Okay, you know that due to electronegative atom like oxygen, there will be what it will do, it will tend to pull the electron towards itself. Okay, as a result, there will be development of partial negative charge on oxygen and partial positive charges on the hydrogen. So in this case, okay, in the first case where you can see that this what I have taken the example. Okay, so this is polarity. First, I'll tell you what is polar and what is non-polar. Polar means polarity will be associated. Okay, polarity will be developed on the molecules due to electronegative differences. Okay, electronegative differences on these atoms. Understood what is polarity? Now, what do you mean by non-polarity? Okay, now what do you mean by non-polar molecules? What do you mean? This you have already studied in PU1, but still I'll tell you. What do you mean by non-polar? Now the molecules such as H2, okay, then you have other molecules like H2, which else I'll take O2, okay, N2. So so this is what hydrogen, okay, oxygen, then nitrogen, right? Is there any electronegative differences? No. The share the bond, what is that? The electrons are shared between the same atoms, right? So there is no chance of development of charges. Okay, the charges they will share equal. If I break this bond, okay, if I break this bond homolytically, okay, now you know what is homolytic cleavage, what is heterolytic cleavage. Now, if I break this homolytically means when I break the bond equally, homolytically means equally, what will happen? Hydrogen, this atom will take one electron and this atom will take one electron. Okay, so this is homolytic cleavage. Now, what do you mean by heterolytic cleavage? Heterolytic cleavage will develop on heterolytic molecules. Okay. Now, as chlorine is a highly electronegative atom, it will tend to pull the electron towards itself. So, this will take partial negative, this will take partial positive. So when this bond will break, hydrogen will have positive charge and chlorine will have negative charge. So it will take the pair of electron, and this is electron deficient. Okay, and this is electron rich. So this is meant by heterolytic and homolytic cleavage. Now coming back to non-polar. Okay, so when you break this bond, so there is no chances of development of charges. Okay, so non-polar means there is no charges. In polar, there will be charges. Okay, remember this now. Now, so coming back to polarity. So whenever you have, when we are discussing about nature of solute and solvent, so you have to remember like will dissolve in like, means polar solute will dissolve in polar solvent, and your non-polar solute will dissolve in non-polar solvent. So these are the examples. Now suppose I take the example first one, NaCl. So NaCl, how NaCl will dissociate? NaCl will dissociate into Na plus and Cl minus. So these are ions. They will dissociate into ions, Na plus. So this will get ionized. Okay, you can see the charges are developed, Na plus and Cl minus. Now I'll write it here, Na plus and Cl minus. Now what is happening? NaCl is dissolving in water. Okay, it is dissolving in water. So I'll write the structure of water. So this is also having charges. This will also have charges. Okay. So what will happen? What will happen here? So there will be association. Okay. There will be what you say. So like this, the bonds are formed. Okay, between the Cl and this. So there will be intermolecular interactions are similar in this cases. Okay, when like is dissolving like, intermolecular interactions are similar. Okay, so you know that positive will attract negative, right? So what is happening here? The interaction, so the salt will get dissolved in water because like is dissolving in like. Now same with respect to sugar also. So sugar, when it is dissolving in water, so there will be the forces will be present due to this intermolecular interactions. They are similar. The polar solute will dissolve in polar solvent. Now going back to non-polar solvent. Okay, when we are discussing about non-polar solvent, naphthalene is also non-polar, anthracene is also non-polar. Okay, this is single, that is naphthalene dissolving in benzene is one example, anthracene dissolving in benzene is another example. Okay, two examples. So non-polar solute is naphthalene and non-polar solvent is benzene. So in this case, what is happening? In this case, so due to the, so there will be present of forces called as dispersion forces. Okay, due to the presence of dispersion forces, okay, due to the presence of dispersion forces, this non-polar will dissolve in non-polar solvent. Okay, is it clear? Are these things clear? So this is about like dissolving like. So this is about nature of solute and solvent. Okay, this is about nature of solute and solvent. Fine. I'll clear this. Next is temperature. Next is what? Temperature. So I'll clear here only. So what is the temperature? So how this will affect? Okay. So we'll see. Okay, temperature. So whenever you are discussing about temperature, you have to remember about temperature is that usually solubility, what will happen? Solubility will increase with increase in temperature, with increase in temperature. So this you have to remember about solubility. So whenever we are discussing about temperature, so solubility will increase with increase in temperature. Okay, and this is very important. So based on temperature, okay, question will be asked of solubility. How is the effect of temperature? Okay, now so there are two cases. Now you know what do you mean by endothermic and exothermic. So whenever we are discussing about temperature, so there will be two types of reaction which occurs based on temperature. One is endothermic, another is exothermic reaction. Okay, now when we are talking about endothermic reaction, we know that delta H will be always greater than 0. Okay, it will be, and it is positive. It is positive. And we are discussing about exothermic reaction. Okay, when we are discussing about exothermic reaction, that time delta H, okay, will be less than 0. So value of 1 will be less than 0, and here the value is more than 1. Okay, now here this will be negative. So this is negative. So for endothermic reaction, delta H will be greater than 0. This is positive. And whenever you have exothermic reaction, delta H will be less than 0, and it is negative. Now, when we talk about solubility in terms of endothermic reaction, so solubility is directly proportional to temperature. Okay, it is directly directly proportional to temperature. So whenever we are discussing about endothermic reaction, here heat is required or heat is released. Yes, whenever we are talking about endothermic reaction, heat is required or heat is released. So heat is required here, right? So whenever the reaction is occurring, that is solute plus solvent, okay, when the solute is getting dissolved with solvent, okay, so heat is required. Heat is required to give you solution. Okay, so this is the reaction in case of what? This is the reaction in case of endothermic reaction. Okay, so heat is required. So what will happen? As the temperature increases, solubility also increases, because temperature heat is required here. Okay, for the solute to get dissolved with solvent, temperature is required, heat is required. So as the temperature increases, solubility also increases. Now, in case of exothermic reaction, what is happening in case of exothermic reaction? When solute is getting combined with the solvent, okay, to give you solution, that time heat will be released. Okay, heat will be released. So there is no requirement of heat here. There is no requirement of temperature. So what is happening? As the temperature increases, okay, because heat is not required, right? Heat is not required. So what will happen? As the temperature increases, solubility will decrease. Okay, solubility will decrease. So yes, heat is released in exothermic reaction. Yes, because heat is released in exothermic reaction, what is happening? Heat is not required by solute and solvent. Okay, understand my thing. Okay, so when exothermic reaction is occurring, heat is not required by solute and solvent. So as the temperature increases, the solubility will decrease. So this is about exothermic and endothermic reaction. So endothermic are only possible. Okay, endothermic reaction is also only possible. So whenever the temperature is asked, you remember for endothermic, it is directly proportional to temperature, and for exothermic, it is inversely proportional to temperature. Solubility is inversely proportional to temperature. Is it clear? Yes. Next is pressure. Next is what? Next is pressure. Okay. Now, how this pressure plays an important role. So pressure has no effect. Okay. It does not have any significant effect of pressure on solubility of solid. As solid and liquid, they are highly incompressible. So you cannot compress. You know that solid and liquid, they cannot be compressed. Gas can be compressed. Okay. If you take in a, what is that? in a piston. Okay, if you take a gas in a cylinder and if you put a piston from above, so gas can be compressed, but solid and liquids cannot be compressed. So it does not have any effect. So pressure does not have any effect on solid and liquid. So remember this. So are these factors clear? So pressure does not have any significant effect on solubility of solid and liquid. So are these three effects clear? Yes, is it clear? Shall we move further? Okay, fine. Okay. So we will move further. So this was about. Next is solubility of gas in a liquid. Very important. Solubility of a gas in a liquid. So now here, what is our solute? Our solute is a gas. Solute is a gas and solvent is the liquid. So this is the solubility of a gas in a liquid. So when we are discussing about solubility of a gas in a liquid, so our solute is a gas and solvent is the liquid. Okay, now what are the factors which are affecting the solubility? So we are going to see the factors which are affecting the solubility of gas in the liquid. First is nature of solute and solvent. Okay, that is nature of gas, that is nature of solute and nature of solvent. Next is the pressure. Okay, next is the temperature. Now, when we talk about nature of solute, so which is the nature of solute? The nature is, we are talking about the nature of gas. Okay, so remember that whenever you have, so solubility of a gas in a liquid is also somewhat affected by nature of solute and solvent. Oxygen dissolves only a small extent in water, but HCl is highly soluble in water because of polar nature of solute and solvent. Yes. So when we are talking about nature of gas, okay, so polar gas is soluble in polar liquid. Polar gas is soluble in polar solvent. Okay, polar gas is soluble in polar solvent. So our solvent is liquid. So example taken is HCl. So HCl is a gas. So HCl gas will dissolve in water. Okay, so HCl. What is HCl? Is it polar? Yes, because chlorine is highly electronegative. So Cl, this will have a partial negative charge. This will have partial positive charge. Water, we have always we have seen that water is a electro negative, right? Oxygen is electronegative, so I'll write it like this. Okay, so this will have partial negative charge, this will have partial positive charge. Okay, so now what will happen here? There will be, okay, so what type of, so due to electronegativity, so due to the difference in electronegativity, the charges are developed on these polar molecules. Now this bond, what the bond between the hydrogen and electronegative atom like oxygen is called as hydrogen bonding. So what type of bonding is seen? Hydrogen bonding. This hydrogen bonding is a very strong bond. So a strong bond is formed. Okay, a strong bond is formed between the polar molecules HCl and water. So when HCl is getting soluble in water, a strong hydrogen bonding is formed. This hydrogen bonding, you can see it is like a dipole-dipole interaction. It is like a dipole-dipole interactions. Okay, between the different molecules, the dipoles are getting connected, right? So this is a partial negative and this is a partial positive. So hydrogen bonding is formed. So hydrogen bonding is a strong bond. So due to this presence of hydrogen bonding, your gas will be soluble in liquid. Okay, the solvent like liquid. So gas solute, if the solute is a gas, it is highly soluble in solvent like liquid. Okay, so this is about nature of gas. So when you have a polar gas, now when you have a non-polar gas, when you have non-polar gas, now you know what do you mean by non-polar gas. Non-polar like gases like diatomic gases like N2, okay, O2, H2. So H2O2. So these are diatomic gases, and these are not soluble in water. They are not soluble in water. They are not soluble in water, because if I take nitrogen, okay, N2, so N2, so there is no partial positive or partial negative charge, because this is a non-polar molecule, and water, okay, water is a polar molecule. So but there is no possibility of any interactions. Okay, so because of this, non-polar gases, they are not soluble in water. Okay, they are not soluble in water. So this is the nature of solute and solvent. Is it clear? Yes. Okay, fine. So moving forward, next is the effect of pressure. Okay, next is the effect of pressure. Next is the effect of pressure. Okay, what is effect of pressure? So solubility of a gas in a liquid is highly affected by temperature and pressure. As the pressure of the gas above the surface of the liquid increases, it increases the solubility of a gas in a liquid. And this is given by something called as Henry's law. This is given by a law which is called as Henry's law. So this we are going to discuss about Henry's law. Okay. So when we are discussing the effect of pressure, what will happen? A solubility of a gas. So whenever we are discussing about the solubility of a gas in a liquid, what will happen? It increases. Okay, the solubility of a gas in a liquid, it increases with the increase of pressure. So as you increase the pressure, the solubility of the gas will increases, and this relationship is given by Henry's law. Now what is this Henry's law? Henry's law is at constant, very important, okay, very important. Henry's law is very important, student. Okay, Henry's law is very important. So at constant, it is asked in exam for 2 marks. Okay, at constant temperature. Okay, at constant temperature, the solubility of gas in a liquid, a solubility of a gas in a liquid is directly proportional to partial pressure. Partial pressure. So this we are going to discuss. Just I will give you the law. Okay. So this is Henry's law. At constant temperature, the solubility of a gas in a liquid is directly proportional to partial pressure of the gas. Okay. That is, as you increase the pressure, the solubility of a gas in a liquid goes on increasing. Okay. So this is about the effect of pressure. Next is effect of temperature. What will happen to effect of temperature? Okay, how will you increase temperature? So temperature is inversely proportional to solubility. Inversely proportional to solubility. Okay, pressure is directly proportional to solubility. Solubility. Okay, and your temperature is inversely proportional. So as you increase the temperature, what will happen? The solubility of a gas in a liquid will increase. Okay, decrease. It will decrease. So as you increase the temperature, solubility in the gas in a liquid will decrease. Suppose I have a beaker. Okay, in that liquid is there. Okay, that is your solvent liquid, and there are gas molecules. Okay, the solute gas molecules are present. Now, what is happening? And I am supplying a external temperature. I am increasing the external. I have applied the external temperature. So what will happen? As the temperature is increasing, the gas molecules which are there present in the beaker. Okay, what will happen? their kinetic energy will increase. The gas molecule, their average kinetic energy will increase. And what will happen to gas molecules? These gas molecules will move faster. Okay, they will move faster. They will move randomly. Okay, they will go and hit the walls. They will go and hit the walls. Okay, they will hit the walls. So what will happen to the temperature? So dissolution of a gas in a liquid, it is a exothermic process. In exothermic process, what is happening? The what you are doing in exothermic this exothermic process, you are the heat is released. Okay, the heat is released. So as the dissolution process involves a dynamic equilibrium, okay, the solubility of a gas in a liquid will decrease in the increase in temperature. So what will happen as you supply the temperature, as you increase the temperature, due to the gas molecule, due to its average kinetic energy increases, they will move randomly and they will hit the walls of the container. Okay, and the solubility goes on decreases. So this is the effect of temperature. Okay, so this is about solubility of a gas in a liquid. So you have to remember this. Okay, so next is Henry's law. Next is the Henry's law. So I have given the statement. What is Henry's law? Okay, I have given the statement. What is Henry's law? So what is Henry's law? At a constant temperature, okay, the solubility of a gas in a liquid, at a constant temperature, the solubility of a gas in a liquid is directly proportional to partial pressure of the gas present above the surface of a liquid or solution. So this is about Henry's law. Is it clear? Any doubts still here? Yes, any doubts still here? Any doubts? Okay. So this is the law, that is Henry's law. Okay. At constant temperature, the solubility of a gas in a liquid is directly proportional. Now, how this Henry's law can be mathematically expressed? Henry's law can be mathematically given as partial pressure is given as P. So P is equals to, okay, KH into, this is mole fraction. Okay, what is KH? KH at, so wait, first let me give you. So partial pressure is directly proportional to the what? That is, wait, I'll write it here. So if the solubility, if it is expressed in mole fraction, okay, when we are expressing this in mole fraction, how it can be expressed? The partial pressure of a gas in a vapor phase is proportional to mole fraction of the gas. So partial pressure is directly proportional to mole fraction. Now, when we remove this proportionality sign, then we have to introduce the constant, which is called as Henry's constant. So this is the Henry's mathematical expression. Okay, that is the partial pressure of a gas in vapor phase is proportional to its mole fraction of the gas, okay, in the solution at a constant temperature. So this is very important, at a constant temperature, because the temperature is constant. So whenever the temperature is constant, what will happen? The solubility of a gas in a liquid is directly proportional to partial pressure. Okay, so this is the mathematical expression. What is KH? KH is Henry's law constant. It is Henry's law constant. Okay, and this Henry's law constant, it will depend on nature of gas. It depends on nature of gas. It depends on what? Nature of gas. Okay, and this chi, okay, it is mole fraction. This is a mole fraction. Is it clear? Yes. So this is your Henry's law. So explanation for Henry's law, we will do it in the next class. Okay, I think this much is too much today. Yes, if you have any doubts related up to here, okay, whatever we have discussed till now, if you have anything, any doubts, you can ask me. I Yes, you can unmute yourself and you can ask the doubts. If you have any doubts. See, okay, Ramya has a question. Why pressure has no significant? Okay. This is on basis of solubility of solid and liquid, right? Because there itself, it has no effect. Okay. So why the pressure? Why the pressure does not have any significant effect? Okay. You have a doubt on this. Here, right? Why pressure has no significant effect on solubility of a solid in liquid. See, what do you mean by pressure? Yes, what is pressure? When we are applying something externally, okay, that is the pressure. Now, suppose I take solid, okay, I take solid, something solid, and I want to put pressure. So does it have any effect on that? No. Okay, pressure does not have any effect on solid and liquid. Okay, it does not have any effect on solid and liquid. That is solubility of solid in liquid. But that is solid is dissolved in liquid, means it is a solution. Suppose I have a solution and I'm putting externally pressure. I'm applying externally pressure. So do the solution has an effect on this? No. Okay, that you take gas, now and you put pressure on this. So there will be some effect, okay, on gas, but on solid and liquid, if, pressure is not applied, or you can say there is no effect of pressure on solid and solid and liquid. Okay, so this is your okay. Crystallization. Okay, see here. What do you mean by crystallization? I told you, right? Now, dissolution was what? When NaCl gives you Na plus and Cl minus. So, okay, so this is dissolution. Your Na plus ions. So your solid is getting, okay, ionized into Na plus and Cl minus ions. Now these Na plus and Cl minus ions, what will happen, which is there in the beaker, okay, Na plus and Cl minus ions, they will start colliding with each other. Okay, they will collide with each other. When they collide with each other, they recombine. Recombine to give back what? They recombine to give back NaCl. Now this NaCl, it will be precipitated at the bottom. It will precipitate at the bottom. This is called as crystallization. Okay. In crystallization, what will happen? Okay, in crystallization, what happens in crystallization, students? Solute particles in the solution will collide. Okay, it will collide with the each other, and they will get precipitated. So this is nothing but your that is crystallization. Okay, and in dissolution, what is happening in dissolution? Your solid solute will get dissolved in the solvent. Okay, fine. So any other doubts? Yes, everything is understood. Whatever has been told till Henry's law. So Henry's law we will be discussing in the next class. So today we have just seen the definition and the mathematical expression. So very important for 2 marks. What is Henry's law? Define Henry's law with mathematical expression. So for the law, 1 mark, and for the expression, 1 mark. Okay. So we'll discuss the about Henry's law and the other factors tomorrow. Okay. So I hope you have understood all the things. You are noting down the important points. Okay. So as you know, chemistry is very volatile. Do you know what I mean by volatile? Did you see this acetone? Okay, the nail polish remover. Okay, girls. Okay, there are many girls now. Okay, so you have the remover, right? To remove the nail polish. So if you keep it open, it will get vaporized, right? It will go. It will evaporate out. So same is chemistry also. So if you do not study, if you do not make the points, okay, for chemistry you have to what you have to do, you have to daily read it. Okay, so just keep the things revising, or please note down the important points. So today while studying the concept, when I'm explaining, you will be like, huh, you have understood. But later, after 2 days or 5 days, it will get evaporated. Okay, so it will get washed out. So chemistry is very volatile. So you have to keep so whenever I'm explaining anything, you make that habit of penning down some notes. Okay, you have to write down some important formulas, whatever has been told. So just make that habit. So it will be very useful. So at any point, if you don't remember, so if you remove that note, okay, you can recall everything. So like that. Fine. Okay, I hope you have understood the things. So I shall end the session here. Okay, we will meet in the next class.